Hi, my name is Linda Perry, and I'd like to tell you a thing or two about origami. Most people, when they think about origami, think about a Japanese crane. But there's much more to origami than just a crane. You can have other animals, like a pig, complete with snout and curly tail. Or you could have a frog. And origami can also be practical. You could have a box, and you can make a toy. Here's a child's toy that's a spinning top. Origami can just be plain silly, like this boat that has 4 legs, or my favorite, a kiss. You can also make complicated mathematical 3-dimensional shapes with origami, like this polyhedron, or this one right here. There's a magical side to origami as well. These 2 rings look like they're probably made out of 2 pieces of paper, but watch. It's really quite amazing. This is 1 piece of paper. There's also a marvelous cascading cube. It's like magic. Today we're going to use the power of origami to demonstrate the Pythagorean theorem. So the first thing I'm going to do is get a square of origami paper, and I'm going to fold it. And the way that I'm going to fold it is in half crosswise first. Make a nice sharp crease. And then I'm going to fold it again, just like a card, like so. Then look at it and notice that you've got the cut ends over here. You've got folded ends over here. For the next fold, you want to put the cut ends together. So I'm going to fold right here on the diagonal, like so. Okay, all my cut ends together. Now I've got the tip of my triangle right here, and I'm going to fold it down along this line. The best way to do this is to show you. I'm going to fold it right here. And the objective is to get a line here that's parallel to this one here. And I could have folded it down further or up over there. It doesn't matter, just as long as I've got this line parallel to that line. When I open this up, I get something that looks like this. And you can see that I've got a square within a square. I've penciled in the lines so you can see them better. The next fold is to fold down along all the square edges. So we're going to do it like so. And when you're done, you're going to have something that looks like this. And again, I've penciled in the lines so that you can see. Let's look at this for a moment. If we examine this, we can see we've got a rectangle right here. These 2 blocks together is 1 rectangle. Then here's another rectangle. And these 2 rectangles are exactly the same. And here's a 3rd rectangle. And here's a 4th rectangle. So 1, 2, 3, 4. All these rectangles are identical. What we're going to do now is to draw a diagonal in one of those rectangles. Here's my diagonal. And you can see that that breaks up the rectangle into 2 congruent triangles. Let's label that so that it's more clear. And that would be this diagram right here, where I have a right triangle, short side A, long side B, and my hypotenuse C right over here. If I look at the diagonals in all the other 3 rectangles, and remember all these rectangles are identical, I can see that each diagonal is C. If I fold these all down, I end up with a square, and the square has an area of C squared. So I have my original origami paper, and I've got 4 ABC triangles that are identical, and I fold them down. And there is C squared. So let's now go back to the original, and take another look. Here is my ABC triangle. This is A right over here, and this is also A. And I've made a cut right over here. And here I have two right triangles that are exactly the same, ABC, ABC, and I fold them down. Over here are again two right triangles that are exactly the same as the first two, and I fold them down. Now look what I've got left. A square that's B times B, which is B squared, and a square that's A times A, which is A squared. So I have my original origami square minus 4 identical right triangles gives me A squared plus B squared. But here I had my original origami square, and I also subtracted 4 identical ABC triangles, and I got C squared. So we've proved the Pythagorean theorem. A squared plus B squared equals C squared.